Hello, everyone, and thank you for joining us for today's session. My name is Danny, and I'm the event planner for the New York Reactor Space. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional, and on topic. Useful links will be shared in the chat. The session is recorded and will be available on demand 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. It'll run for approximately 1 hour with time for questions throughout. I will now turn it over to our speaker for introductions.
Hello, everyone. My name is Nitya Narasimhan. I'm a senior AI advocate on the developer relations team at Microsoft, and I'm super excited to welcome you to episode 3 of Model Mondays. And I want to bring along my partner in crime, Sharmila Chokalingam, as we kind of walk you through our agenda for today. Hi, Sharmila. How are you feeling about today?
Hey, Nitya. Doing really great. We just came back from NVIDIA GTC, so lots to talk there.
Yeah, I can't wait. I heard you met some interesting people.
Yeah, interesting people is putting it lightly. We met Jensen, and he came to Microsoft Azure booth, and we gave him a demo of the announcements we made at GTC, and I got an autograph from him. So that was the highlight for me.
Hey, I'm 1 degree away from Jensen now. This makes me feel good. And I know a lot of people asked us this question, so we put the slide up. So what exactly is Model Mondays? We recognize that we're all feeling overwhelmed by the pace of kind of innovation in the AI model space. So with Model Mondays, it's a 30-minute show. The first 5 minutes, we'll actually kind of catch you up on the news. We call it a 5-minute highlight segment with Sharmila. And then we'll have a 15-minute deep dive with our featured speaker, Neil Gokhale from Cohere. So stick around for that. But I want to turn it over to Sharmila because she's coming back from GTC and she's got a lot to tell us. So Sharmila, take it away with Model Mondays highlights.
Thank you, Nitya. Now let's get started with the Model Mondays highlights of this week. So last week, it was NVIDIA GTC, and we unleashed a flurry of exciting announcements. Now let's face it, the AI world isn't slowing down, and neither are we. As more companies shift from let's test this out to let's ship this, inference is officially having its moment, and we saw that in all the announcements that were made last week. And of course, at Azure, we are ready for it. First up, we kicked off things with a bang by announcing the availability of NIM microservice models on Azure AI Foundry. These models, you're seeing a list of models listed below. So these are just the first set of models that we brought to the catalog, but we're going to add more and more models, more optimized models from NVIDIA into the catalog. So keep an eye out for it. And these models are supercharged for deployments at scale. Now I have a video in there. I'm not going to play it now, but it's going to be in the repo, so go check it out. And as I go through these slides, also look at the QR codes, take a screenshot. It'll take you to the model card so you can play around with it. Now let's move on to the next one. We're going to talk about how we are making it easier than ever to work with teams of AI agents. Again, this is an announcement we made at GTC. So now not just one model, but multiple agents can collaborate, reason, and get things done together. So we announced that we are integrating the NVIDIA Agent IQ open source toolkit with our Azure AI agent services. So now we are offering a seamless way to connect, profile, and optimize these AI agents. Think of it as your control panel for intelligent task orchestration. These agents aren't just running isolated tasks, they are now equipped with enhanced semantic reasoning. So that means they understand not just the words, but the intent and context behind them, enabling smarter decision making. So in short, we are not just connecting AI agents, we are turning them into a cohesive, intelligent team that can think, adapt, and execute together. And moving on, again, an announcement at GTC. We've been busy working with NVIDIA, Meta Llama to make their models faster to run. So we have rolled out serious optimizations that deliver state-of-the-art inference performance. So what does that mean for you? It's blazing fast responses, smoother deployments, and way more bang for your compute buck. And the best part, all of these performance gains comes without sacrificing response quality. You will get the same sharp, intelligent output, just delivered quicker. Now, it's like giving your AI a high performance upgrade without touching the personality. And all these are rolled into the Llama models by default. So if you're already using a Llama model, you're covered. And if you're not, start using it today. Now, again, this announcement that we made at GTC might have been under the radar, but it's still an important announcement. We announced that we are bringing Mistral's latest Mistral small model to the catalog. So don't let the name fool you. It's still a multimodal, multilingual, and highly capable model. So what's really cool is that it's been optimized to run on consumer-grade hardware. So yes, you can get a powerful performance without needing a data center in your basement. And that's the name of the game now. And in terms of how it stacks up, Mistral Small is playing in the same league as Gemma 3 and GPT-4 mini models. So whether you're building apps, agents, or just tinkering at home, Mistral Small will give you the big brain energy in a budget-friendly footprint. And finally, we move on to an announcement that was not made at GTC, but was made at the Adobe conference, where we announced that along with Cypher, we are bringing their shiny new model, Cypher's model, into Adobe Gen Studio along with Azure AI Foundry. So we are bringing AI-powered compliance to all the marketing content. So yes, now even your AI-generated content can play by the rules and go to market faster. It's all about giving financial services teams the power to create content that's not only smart and beautiful, but also compliance approved. Think of it as fewer legal headaches, more high-fives from the compliance team. Thank you. That wraps up this week's Model Mondays highlights. And now we go. I will hand it over to Nitya. Thank you, Nitya.
Hey, thanks, Sharmila. So what you're telling me is I need to return the data center I ordered from Amazon for my basement.
You do have one? Okay, that's great.
I really like the analogy. We should use that more. But I will say a lot of people ask me, hey, when's Mistral coming? So I'm super excited for that. Hopefully we can kind of like do more with that model down the line as well. But speaking of models, I think it's time for us to talk about our featured model today. And before we kind of bring our guest over, I thought we should give folks a reason for why we picked this particular kind of category, if you will. So I know you had some thoughts on that.
Yeah. So of course, like with a lot of importance on AI happening right now, a lot of companies are looking at the troves of data that they have and how to use that data in their AI applications. And once data comes into the picture, if you're not talking about some small amount of data, like it's, as I said, troves of data. So we companies need a very efficient search and retrieval system, and whatever has been there, the legacy systems are not helping anymore, and especially coming up with relevant results. And I'm pretty sure that's Neil is going to cover some of it. So I without too much going into the details, I want to bring in Neil Gokhale from Cohere. He's a solution architect and an AI advocate. So welcome to the show, Neil. We are super excited to have you here. You're our first external guest speaker. We did have a guest last week, but she was from Microsoft. So it's nice to have our first external speaker from Cohere. And we have had a long-standing relationship with Cohere. We've been launching a bunch of your models. So excited to have you here. Please go ahead. What are you going to talk about today?
Yeah, sounds good. A lot of pressure being the first external guest, but I'll do my best. Pleasure to meet everyone in the room and also watching externally. My name is Neil. I am a solution architect at Cohere. And today we're going to talk about search retrieval, as the slide says. So I've kind of explained it pretty well in the video. I'll let you guys stage that up. and hopefully we can get to some pretty interesting questions as to what these models are.
Let's
But
do
pleasure
it.
to meet everyone. Hey everyone. I'm probably reintroducing myself here, but nice to meet you again. My name is Neil Gokhale, and I'm a solution architect working at Cohere. At Cohere, we build language models, and we also build tools that leverage those models for enterprise generative AI. We have the pleasure of a strong partnership with Azure, and we actually host a bunch of these models on the Azure AI Foundry, and we're going to talk about some of these today. The focus for today's talk is search and retrieval, and how that plays a massive impact in unlocking true generative AI capabilities for the enterprise. So I think it's worth to actually start off by talking about who Cohere is and what we're known for all those people that may not have heard of us by now. So our company was founded in 2019, but I think it's actually worth it to take it back to 2017. That's around when our founder, Aiden Gomez, co-authored the Attention is All You Need paper. This was the seminal paper that coined the term transformers and is responsible for the T in GPT, but also the craze that we've been on for the last 2 or 3 years of generative AI. We're at this point about 400 employees deep, spread across many different geographies across the world, and we have 4 offices in Toronto, San Francisco, New York, and London. What we're known for in this extremely competitive generative AI space is our laser focus on unlocking generative AI for the enterprise. So we do this by strong generation models under the chat endpoint. Our command family is able to generate textual content at high quality from textual prompts. On the other hand, we also have strong search and retrieval models, which allow for enterprise search as well as RAG. We have embed and re-rank. Embed obviously being the model that helps you generate embeddings from text or other modalities like images. Re-rank is actually going to be the focus for today's talk. It's a model that we're known for. It's a state-of-the-art ranking model, which takes text content as well as a user query and then ranks them based on semantic relevance. We also offer customization and multilinguality, which is something that you'll see across all the models here. So all these models can be customized, and they also operate in many different languages other than English. All 3 models, as mentioned, are available on Azure AI Foundry, and you can get access to them very easily and start playing around with them yourselves. So, as you've probably guessed at, since I've mentioned it maybe 5 or 6 times at this point, today is all about search and retrieval. But let's put it within the context of something that I'm sure everyone knows of at this point. Let's talk about RAG. Specifically, the 2 major components of RAG. So when you look at a RAG pipeline, you look at retrieval as well as generation. Now, the generation is pretty self-explanatory, right? You take textual content in the form of a prompt. That content usually has a bunch of documents or context that can help you answer the question. And these large language models are strong now to be able to generate high-quality answers that are grounded on whatever context has been retrieved. So we tend to fixate a lot on these generative models, which makes sense. They're getting bigger, they're getting better, and the hype generally is centered around these models. But our philosophy from day one was that along with strong generative performance, we need extremely strong retrieval. You need to get the right documents to the model for the model to be able to generate a good response. So we place heavy importance on retrieval. And I think it's fair to talk about how retrieval can play a role in enabling better generations. So not necessarily ignoring the generative side, but let's think about retrieval a bit more, specifically how we can make it better. So if you've built a RAG pipeline out, I'm sure you've gone through some of these steps. You might have started by introducing semantic retrieval. So you can think of retrieval in terms of keyword search or lexical search, which matches keywords, or you can get more advanced and start including things like embedding models. This introduces something called semantic retrieval, which means get me documents based on their relevance, but also understand the context behind the words within those documents. So semantic retrieval drastically improves the scope of your search since you're not just keyword matching anymore. Now, on the other hand, you can also improve the actual searchability of the chunks. How do you make sure that the documents that you have in your data stores are more searchable? Do you add metadata to them to ensure that there is more matchability, or do you chunk them into different blocks so that a retrieval model can pick them up better. Both are equally important, but to add on another layer of quality, maybe try adding a re-ranker to further enhance the precision of your search. And this is a common theme that we're going to follow, and maybe you'll see in the demo as well, is how re-rank unlocks search precision. So what is a re-ranker? Very quickly going through this. A re-ranker is a specialized large language model that ranks text content against a query, typically a search query, and orders it in terms of relevance. So on the one hand, you might come in with a search query and you might provide it a bunch of documents. In this case, I've just exemplified it as a bunch of text. You throw this into the re-ranker. In our case, it's called re-rank 3.5. It's our strongest model out there. And what this does is it generates a relevance score using the transformer mechanism. So a relevance score is generated for each document, and then you can use this score to sort the documents based on that relevance. And you'll be surprised to probably find out that some documents that were way lower in your initial ranking now suddenly become way more important because the re-rank model is laser focused on figuring out which one of those is the most relevant to a search query. So why use re-rank, right? I think we've all used RAG, we've all used an embedding model. Maybe we've also looked into hybrid search. Where does that re-rank model come into play? And how does it improve my workflows? So in search, re-rank unlocks complex query retrieval while improving relevance. So if you're just looking to retrieve documents, right, and maybe you have a search bar on your website or in your product, re-rank can actually be stacked on your existing search solution. So let's say you have your data sets connected to a lexical or a keyword search. You may have them connected to semantic search with an embedding model, or you may have a combination of both, a hybrid search mechanism. After your first stage retrieval, which is the first pass of the documents that have been retrieved, you can throw them into re-rank and pass the search query, and re-rank can actually rank them further based on a more precise understanding of what you really want. Re-rank 3.5 actually takes a step even further by unlocking complex query retrieval. So asking things not just, simplified to, hey, find me pizza. You can ask it, find me all the pizza restaurants in Toronto that have a quiet ambiance and are not too far away from the city and have reviews starting 2019. That query in verbatim can be passed into a search bar, and re-rank will do the job in terms of getting the documents that are the most relevant surfaced at the top. Now in RAG, re-rank also balances recall and precision. And why this is important is because it directly impacts your efficiency while maintaining high quality generations. So recall, you can think of it as get me the most amount of documents that are relevant, or every single document in my data store that is relevant. And precision means get me the most relevant document. And by including re-rank into your search flow, into your search pipeline, you can actually balance both of these things out. So the way you would build a prompt for RAG is you would set up a prompt by saying you are a helpful chat assistant. You would mark where the context takes place. So here are some documents that may be relevant, but also add an instruction that says, hey, note that the higher the document is in this order, the more relevant they are to answer this question. Re-rank 3.5 can be used to retrieve the documents, which will be appended to the context, and then you can pass your user question. And this prompt will get you better generation quality with a smaller number of documents that you can pass, so that obviously improves the efficiency of that search, as well as the efficiency of the generation, but also ensures that the high quality response is preserved. Cool. Now let's move on to a demo. So let's take a look at how re-rank works in action. We have a pretty simple demo set up here that shows you how it can semantically add a boost to the search quality of your products. So I'm going to click on this Amazon catalog setup that we have. And essentially what it is it compares lexical search, which is keyword-based search, to the search that a re-ranker would do, specifically our re-rank 3.5 model under the hood. And I'm going to type a few different queries. So let's start off with shoes for formal business event for men. Notice that this is a multi-aspect query. So I'm not only asking for shoes, but I'm also asking for shoes for a formal business event. And I'm also assigning a gender to the search. Now, when I hit search, On this side, you'll see the lexical results. And if I just zoom in very quickly onto this particular shoe, this is certainly something I wouldn't wear for a business function. But then when I click this button, you'll see what re-rank throws out. And you'll notice that the first few results are pretty similar to and pretty relevant to what I would need based on my search query. And the other interesting thing here is that you'll notice how re-rank has actually scoped up the rank of these searches. In this case, it's from 296 all the way to 1. In this case, this was item number 297 in the order, but by applying re-ranking on it, it brought it up all the way to number 2. So hopefully that shows you very quickly how re-rank compares to a traditional vector search or even a lexical search in this case. In the second demo, we're going to look at something very similar. In this case, we're actually going to compare a pretty simple embeddings-based search methodology to another option where you have an embeddings model. So you have semantic search, but then you stack re-rank on top of it to augment the precision of the search. So let's just drop some example queries. I'm going to search first for shoes. You'll notice that actually at this point, the results should be pretty similar. And that's because it's a pretty simple search query. Once again, when we get into multi-aspect queries, like for example, if I select this one, shoes for women less than $80, there's multiple aspects that you actually need to search for. But by typing this in natural language, you'll see that a traditional vector search system may give you results, but if you scroll through it, you'll notice that this is actually more than $80. And that seems to continue. But looking at re-rank, we do have shoes for the right gender, but they're also consistently less than $80. And once again, what we're passing into these models is the description text over here. So just based on that, the model is able to correctly give you the right output. So here again, you see more options, and the price is always less than 80, and the gender is always assigned correctly. So that's the power of the re-rank model.
All right, I think we're back on. So that was actually kind of exciting. I'm a huge fan of RAG because we've been doing a RAG-based sample on Azure AI Foundry, and I'm so glad we have Azure Cohere Cohere models not only on the Azure AI Foundry model catalog but also on GitHub. So there's ways for people to start getting to play with it right off the bat. But I want to see if there are any questions from the audience. In the meantime, Sharmila, do you want to kick us off with one?
Yeah, I had a question actually. It's great looking at whatever you showed, Neil. One question I had is how well do these models generalize across like languages? You did talk about it a little bit, and also across specialized domains like legal or medical domains.
Yeah, great question to start us off. So from a language standpoint, it's actually a key piece when we built re-rank. Re-rank supports over, I think, 100 languages. So what that means is, let's say my query is in English and I actually have documents in Japanese. You can still retrieve them with high quality. And we'll continue to expand and make that even better with our progressive models. In terms of domain specificity, when we train these models and we try to make re-rank 3.5 better, it's something we heavily incorporate in the training lifecycle. So domains like legal, for example, manufacturing, things like that, those are always accounted for when we build our data sets. So yeah, we want good performance in both cases.
Okay, got it. That's great. And I do see a question on the chat. The question is from Shubra, and she asks, does this happen because the generic algorithm is based on fuzzy algorithm, or okay, you see the question that accepts few margins around the parameters?
Yeah, so I like that we're getting deep and technical this early. So re-rank is actually a cross encoder. So it's not similar to like a fuzzy search or even like a sparse embedding. It's fundamentally something that compares every document that you send it, whether you chunk these or you send it as a single document, against the search query. It uses a mechanism called early interaction to figure out what is the best and most relevant document. And ultimately, you would sort these results on that relevance factor to get the best documents or the most relevant ones to a search query. Hope that answered your question. But there's a lot more documentation that we'll share on our blogs, which kind of go deep into how this kind of works behind the scenes.
Yeah, and I wanted to take a minute to tell folks that we'll hopefully have an AMA with Neil on Friday. So if you don't get time today, definitely show up there. But questions are coming in thick and fast. The next one up is there are ways to fine tune for a specific domain or industry.
Absolutely. So we want to customize, right? Like one thing we realized very early on when working with the enterprise is we can go in with strong, very strong general based models, but the moment people want to customize, we need to have that configurability. So yes, we have a very easy setup to customize your rank with domain specific data. So yeah, that's something we can for sure allow.
And I think there's another question. It says, can we adopt customized ranking or is it configurable?
Yeah, so in terms of the spectrum of how you could customize it, there are ways to focus re-rank search. The way you do that is along with passing your raw documents, you can also actually pass metadata. So for example, if my documents from a folder had authors, date tags, edit tags, things like that, I can actually incorporate that in my documentation to scope the search of the query. If you want even more fine-grained control, the best thing to do is to actually fine-tune the model, which, as I mentioned, we can very easily do.
Awesome. I had another question.
Sure.
What's some of the common challenges customers are facing when they're trying to integrate like Cohere search models into their existing systems?
That's a good question. I think maybe I'll talk about re-rank specifically.
Yeah.
When we think of RAG, I think it's very easy to build a RAG pipeline which has an embedding model and then also a generative model. So that's what people are used to. So when we bring re-rank on the table, it's something that's completely new. So naturally, the questions we get are, how do we incorporate this? Is it the right fit for us? More often than not, we find that re-rank does help search quality, and we've placed heavy importance on how you can actually build it in. So if you look at, and we'll share some code notebooks for this, but it's 3 or 4 lines of code at the very most, and it's very easy to use. It's very easy to trace. So it's something we're trying to make as applicable as possible across all our customers.
Okay, got it. Do we have any more questions, or can I ask another question?
Go ahead. I'm keeping an eye on the chat.
Okay, I'm just because now agentic workflow and agents are the theme, and everyone is talking about it. I'm just wondering how Cohere approaches that, like search in multi-agent or agentic systems, and do these models play a central role in that?
Absolutely. So I think that scales across the board, right? We have strong generative models for agentic workflow. So we released a new model called Command A, which should be on the Azure Model Foundry very soon. So we're excited for that. But I think equally, we want to make sure that our search retrieval models are also capable when it comes to agentic workflows. So that the idea that re-rank can now support multi-aspect complex queries is a direct factor for that. Because I think in agentic workflows, typically, me as a user will ask for something that is very detailed. I'll ask the model to do this, and then after that, do that, take the results, summarize them, things like that. So re-rank has to be resilient to these multi-aspect queries and make the right search, which is why we built that model up that way.
Awesome. Nitya, do you have any questions? I can keep going.
No, I do, because we've been building RAG systems, and I think when we go out in the community, we usually get 2 questions. One is related to evaluations. Like, so for example, you kind of mentioned it, like you have tracing support and you can kind of look at, but are there best practices for evaluating responses? And the second one inevitably is cost. Like, how do we make these systems more efficient? And I know people are looking at various techniques. So best practices for those. So cost optimization and evaluation.
Awesome. I'll answer them in order. So in terms of eval, what we internally evaluate re-rank on is something that is a pretty common kind of metric in the industry for search retrieval. It's called NDCG. It just means ensure that the right document in my search stack is surfaced properly. And then also, because re-rank, I mean, it's in the name, it cares about ranking. The order matters of these documents. So if you have a way to evaluate that, it should be a very easy kind of solution to figure out if it's effective for your search pipeline. When it comes to cost efficiency, I think re-rank tries to directly address that. So in a typical RAG pipeline, if you don't use re-rank, to get the same sort of quality, you might have to throw in maybe 100 documents that you've embedded. So what inevitably happens is that the language model that you're using gets those 100 documents fed into its context, and it has to process all those tokens to get a solid answer out. So by including re-rank, you can actually scope that down to maybe 50 or even 10 documents, because those documents are going to be super relevant. That means there's less tokens that the language model has to consume, thereby imparting a level of, I guess, efficiency in terms of latency, as well as cost, right? So you're trying to impact both vectors to get better performance.
So I can't believe that the time's already gone by so fast. So we have to wrap. And I want to just let folks know that we do have visual generative models with the Stability AI team next week. So don't forget to sign up for that. But I have to leave by saying there's been so many questions. We will have an AMA on our Discord on Friday at 1:30 p.m. Hopefully we can convince Neil that he needs to come back. And we will also have picked up a whole bunch of these questions to answer there. So please do come meet us over there. And thank you all so very much. Sharmila and Neil, final thoughts as we wrap?
No, I think this was a great episode. I did have a few questions. Maybe I'll use it for the Discord. We'll talk about it more. It was questions around the future direction of Cohere as well as search models. So I wanted to hear your thoughts on it. But this has been great. Oh, we have one final question coming in. Do we take it, Nitya, or?
I think, Danny, I think we should be able to take one, but we should wrap right after. They might drop us off the channel.
Yeah. So the question is, does the complex query capacity of the re-ranker work by default? And is the model fine-tuned to recognize documents that could potentially help to answer a query?
Yes and yes. I'll be very quick.
Okay, awesome. Please, if you have more details, if you want more details on those questions, stop by on our for the AMA or on our Discord channel on Friday.
Yeah, and I'll also, just for the folks who asked, we have these 3 resources. So we'll make sure that we post the links in our Model Mondays repo with all the information you got today as well. Thank you all very much.
Nitya, I'm not seeing the 3 resources. I don't know. Oh, yeah, great.
Yeah, there it is.
Yep. Thank you. And thank you so much for stopping by and spending some time with us. This was great having you here. And looks like the community also enjoyed your talk and have a lot of questions for you.
Awesome. Bring them on.
Yeah. Thanks, everyone, and see you next Monday.
Yep.